Okay, enough awkward videos. Now you have the real me. Um, Welcome everyone. Today I'll be talking about chaos engineering. Who of you have ever heard of chaos engineering or ever tried it before? Only a handful. Okay. Um, well, let me quickly introduce myself and then get going with the actual content. As the video explained, my name is Geert van der Cruijsen. It's quite an unpronounceable name in any other country than the Netherlands. I work for Geert, which is a consulting company where I basically help teams build better software. I'm a software engineer myself, and I go into teams often as a coach, DevOps coach, where we implement all kinds of DevOps principles, but also improve their software architecture and those kinds of things. I like to call myself a full cycle developer because I like to, well, build software, but also run it in production. I believe as a developer, you should be responsible for, well, the full life cycle and not throwing it over the fence to someone else. So chaos engineering, well, why would you actually need chaos engineering, right? Well, let me explain to you a couple of examples. Who of you works in a large enterprise that does like every few months or every 6 months they do a large failover test from one data center to the other? Anyone? Yep. Do you like that? Guess no, right? Often the whole teams have to go on a Saturday, and well, they do a full failover, and well, after that you just roll back to your initial data center. But it takes a lot of effort and a lot of free time for people. And next to that, our software is becoming more and more complex. So, do these failover actually work, and is every 6 months enough to do that? And software is getting a more well important role in our lives as well, right? If we look at well some of these news websites, software is really becoming really important in our lives. And if you look at downtime for a certain application, it can cost millions of dollars, right? So, well, if you look at Amazon, they're a nice example, right? They're the biggest web shop in the world, and they actually have a Prime Day, is what they call it, when there's a special day in the year that they invented themselves, where they give, well, large discounts to people. And especially during this day, last year they had an outage of 1 hour, and when they calculated it, it cost over 100 million, that 1 hour of downtime. Well, I think those kind of companies really want to invest in building better resilient applications so they don't have these kinds of outages. Well, same for Delta. Their infrastructure was down for a couple of hours. Because of that, a large number of flights was cancelled, costing millions again. So we're going to try to avoid that. But how do we do that? Because our applications and our infrastructure is becoming more and more complex. Anyone have an idea of what these, well, big balls of mud are? Well, they're actually microservices architectures from one of the, well, larger internet companies. So on the left, you have Amazon.com, and it's only Amazon, the web shop. So it's not AWS or anything. It's just all the microservices used in Amazon worldwide to deliver Amazon in each and every country. On the right, we have Netflix, which is one of the well, leading companies doing microservices as well. But yeah, they have to be all over the world as well, and they have quite a complex architecture as well. These architectures are too hard to grasp as a human, right? Well, they don't have any value for us, these kind of pictures, except for showing how complex it is. So, well, how do we work with these kind of architectures? How can we measure if our application is still up? And basically, we have to make a mind shift, because when you have these kind of architectures, and I'm not expecting all of you to have those complex architectures like Amazon or Netflix, but when you're going into distributed applications and building microservice architectures, your architecture will become more and more complex. And in those kind of situations, you actually have to make the mind shift that you expect that, well, our application is never fully up. But how can we cope that while our application is not up, can we still serve our customers a certain amount of content, or can we still make our customers happy during our service while certain parts are not functioning as we expected? Over the years, we had several different monitoring tools, checking for CPU usage, memory usage, those kinds of things. Does that still work when you have thousands of servers running in production? What does this information give us? We should really make a mind shift to measure different things, measure more and more into what actually is the user impact that we have, that our application have. Maybe when half of the servers are down, maybe we can still serve every customer without any problem. Those are the things that you want to measure instead of, well, we have 5 servers which are running at 100% CPU. That doesn't say anything about how the application is used in production by our users. And Netflix has they're really in the forefront of measuring these kinds of things. And they have a really nice blog about this, and they measure user impact by how often the play button is actually clicked by all the users combined. And they call this the pulse of Netflix. And they have these graphs, and because they have a quite steady amount of users where they can measure, well, each time of the day they expect, 1 millions of clicks should be happening each minute. And when things are happening to their users, they will see an increase or decrease in the amount of streams started. So they just measure the amount of play button clicks, right? So when the streaming service does not work, people will keep on clicking, keep on starting new streams because, well, the streams itself don't work. And they see this spikes in amount of clicks per user increase by a lot. When some UI isn't rendering well, those play buttons will be clicked less. So it's also an indication that certain things are not okay. And well, by doing those kinds of measurements, you actually see like when should you change something in your application? When should we fix certain things, or are we still okay with our application while these servers are not functioning properly? But we should measure more than just availability. If you check these, check a lot of talks or blogs by people, all the health checks, they often check like, does our server actually return a HTTP 200 OK? That doesn't say anything, right? So yeah, our application is still responding, but is it responding with the right data? Is it actually showing the stuff that users were interested in? So looking at reliability, there's a number of factors that you should also take into account in, is our application up or not? So availability is one, and of course it's an important aspect, but there's far more that also are really important. So I highlighted the ones that are also important to users. The grayed out ones are also quality measures, but they're more like internal as a development team. So availability is one, but latency. Is your application responding as fast as it was before? If users have to wait longer, they're also the chances higher that they will actually stop using your service or go do something else. Throughput, correctness, also really important aspects of, is my application working correctly? Right, my page could give a 200 OK, but if it's showing cached data, it's not showing real data that's current, well, that might have a business impact as well. So we're going to look at how can we build resilience applications. And there's a number of factors to actually build these applications. Well, the first factor is infrastructure, right? We already shown the big infrastructure pictures of Netflix and Amazon. So yeah, we can we can look at building infrastructure that's resilient while by having multiple copies of things, those kind of things. But there's several layers of things that we need to look into when we're building resilient applications. Next one is network. Well, we all know the network is not reliable, right? So we have to take into account that, well, a lot of network calls will fail. We have to build in retry mechanisms, circuit breakers, those kinds of things. Next one is the application layer. The application itself could also fail, right? There could be error messages, code that's not functioning correctly. We have to look into those as well. And lastly, we have people, right? People have a big impact on how our software is functioning. How are people, especially developers or operations, how are they interacting with our application in the background, right? Are they changing certain things? Are they deploying things? What does this impact? How does this impact the resiliency of our application? One of the things that I like to take into account as well when you're building resilient applications is you already did your mindset shift that, well, things will fail. But how can we fail in such a way that it doesn't impact our users too much? And it's a pattern called graceful degradation. But what I really like, and Netflix is a front runner in this as well, is the notion of fail open. When something is going wrong, how does this impact the users? And Netflix have a really great example in this for example, authentication. What happens if your authentication server is not working? Well, people can't log in, people can't use your service anymore, right? That's a normal decision that we as developers would make. What Netflix did is, if authentication server is not working, we will just give every user access to all the content. So all the users are happy, and well, users are happy, so that's the end goal, right? That's what we want. It's our fault that they can't log in. We messed up the authentication server, so we need to fix it. And during that time, we will just give everyone all the options to watch all the streams. I think that's a really good mindset shift to have, to look in these kind of scenarios of how can we change our applications so we don't impact users when failing. And of course, it doesn't work for every scenario, right? If you're building a banking application, you just don't open all the bills to everyone. That's not how it works. But there are always scenarios that you can come up with these kind of scenarios and try to fail open where it's possible. A lot of people say, yeah, well, we do a lot of testing, right? So we know our application is resilient. But the problem is, when you're doing testing, you're always testing for the known things that can go wrong, right? We do unit tests. Well, how does a unit test look? We have a unit, we put some stuff in, and we have an expected outcome, right? So we check if the outcome is what we expected. Same for integration tests. We have input again, we pull it through some services or components, and in the end we can check our output again. So how is testing different from chaos engineering? Well, in chaos engineering we actually test for the known unknowns, right? So there are certain things that could go wrong, which we don't know yet, and we're just going to experiment with injecting some harm and see if we can cope with this. Right? I saw this similarity into adding vaccinations, right? You add a little bit of harm through your vaccinations to see if your body can cope with this disease. That's actually what we're trying to do with chaos engineering as well. So when I ask people, do you know what chaos engineering is? Well, a lot of people say, yeah, that's just killing random servers in your network, right, and then seeing what happens. That's not what chaos engineering is about. chaos engineering is doing experiments that should not impact users. So don't do stuff killing random stuff. That's not what chaos engineering is about. This is the official definition of what chaos engineering does. Chaos engineering is. There's a website called Principles of Chaos, and on this website, the community of chaos engineering, they came up with a official statement, and it's about. I highlight a number of important words here. It's about doing experiments. So yeah, experiments are similar to tests, but we test unknown scenarios. And what we try to do is we try to build confidence that our application can actually handle certain scenarios. So how would this look like? It looks a bit like an integration test, right? So we have input again, we put it through some servers, and then in between we will just add a little bit of chaos. This could be a number of things. In this example, we could either fail one of the network calls, or we could just add a little bit of latency and see what happens. So these experiments, like what kind of things could you inject, right? Well, one of the simplest examples is just a host failure, right? We do a network call and we don't get any response back. We could increase the CPU load or the memory usage on certain servers to certain amounts, see what happens. What happens if one of my servers has 100% CPU load while doing this this service call? What will happen? We can make applications fail, right? We can inject stuff in applications so we can see what happens. Well, when one service is calling the other service and it's returning a 500 exception code, what will happen to our application? Then we have network attacks, like we can add a bit of latency, we can add packet loss. What will happen to our application when these things happen? And one of the examples, I don't know if any one of you read the Phoenix Project. It's one of the it's a novel about DevOps. And what in the book there's one guy called Brent, and he's the best developer you have in your company, right? Every company has this one guy that knows everything. Well, that's Brent. What happens if Brent's not there? What happens if Brent's hit by a car? A lot of companies will have quite a large problem. So, this is one of the easiest things to test, right? Just send them on a paid vacation and see if you can still cope with your application. So, chaos engineering, is it something we should only do in production? Well, there is no place like production, right? That's where all the magic happens. But this guy over here, I don't like this this meme because testing in production is part of chaos engineering. It's when we build a certain level of confidence, it's something that we should do. But it's not the only kind of testing we need to do, right? We still need to do unit tests. We still need to do our testing pyramid. That's the basics that we need to start first, and then when we have a certain amount of confidence, we can move to doing tests in production as well. So how should you start doing your own experiments in your own applications? In chaos engineering, a lot of companies will call this a game day, and a game day is a day where you gather everyone involved in your applications, from people who develop it, so your developers, operations, people, network engineers, anyone who is remotely connected to your application and keeping it up and running. Have those guys in the same place, so you can start doing these experiments, and when things might go wrong, you at least have all the people available there to get stuff working and fixed again. And these kind of experiments, the flow really looks like something that a lot of teams are already doing, which is called incident response learning. right? When you're doing your application currently, when something happens, when an incident happens, I hope you try to learn from those as well, right? So when an outage happens, afterwards, when the outage is fixed, you often do a post-mortem or check why did our application go down. You fix it, you learn from it. So how can we make sure that this doesn't happen in the future, right? That's the improve phase. Then you go back to normal. Well, in incident response, what you do is, well, we wait for another outage again. Well, that's where the difference is with chaos engineering. We're not waiting for an outage. We're going to create our own, right? That's where we do these experiments to create these small outages to see if our application is actually holding up to what we believed it could do. So, looking at such an experiment, how would we create this experiment? First of all, we need to start with a steady state. We need to know how our application is actually doing in normal circumstances, right? Normal circumstances. So what you need to measure is, again, these business metrics, right? Not memory usage or CPU load. No, how is our application doing for our end users? For example, in Amazon, they also measure like how many sales do we do, etc. When Amazon did such an experiment and they increased 100 millisecond load time, their sales actually dropped by 1%. Say, what's 1%? Well, if you look at Amazon sales numbers, it's quite a large amount of money. So when we have this steady state, we have this this application, we have a certain routing going to our service that we want to test. What you would like to do is, we have a certain service, we would create a control service and a experiment service next to each other, and you're going to route a certain amount of traffic to both of these extra instances. The control service is just to see, to compare with your service under test. So what you could do, for example, and these numbers really depend on the amount of users you have or the type of application that you are building. But for example, you would just route 89% of all your users, you would just send them to the normal service that you have. The 1% you send to the control service, and another 1% you send to the experiment service. And initially, this 1% could be your internal people or your alpha users. It really depends on what kind of control you have within your application. And then with the experiment service, what you're going to do is inject these kinds of failures, right? So when this experiment service is trying to call service B, we will just kill the network request. We will just add delays and see what happens. So one thing that's really important to notice is always be able to abort these kinds of experiments, right? You might think, well, we have everything under control. 1% of the users, we can manage that. But things might happen like cascading failures, right? If one service goes down, it pulls down other services as well, and well, before you know it, you might have quite a large outage. So always be ready to abort your experiments. So after we have a steady state, what we do then is, well, we define a hypothesis. And what that means is you bring all those guys into the room, that everyone that was involved in keeping your application up and running, and you start brainstorming on, well, what would happen if our database was unavailable? And having this brainstorm is actually quite funny when you do these the first times with your team, because, well, you might expect that everyone expects the same thing to happen, right? But, well, the architects will say, well, if the database is down, then we will just use the cache for a while, and, well, maybe one of the developers will say, well, I think it will just crash and burn. And it might be that some network engineer has opinions as well. So bring in everyone, right? So developers, operations, network, the business, they're also important. What happens to our users? If the database goes down, can we show them a cache? How old can the data be business-wise until it doesn't make sense? So get everyone in, testers as well. They often have a really good view of things that could go wrong. And then you start brainstorming on what could go wrong, right? So what happens if the database goes down? What if our load balancer stops working? So what you want to do with an experiment is come up with an experiment that your application should be able to withstand, right? So if you say, well, if our database is down, we always have a cache. So if a database is down for 5 minutes, our application should be able to withstand this. Only continue when you all believe that your application will hold this. If you know that your application is not going to live through this experiment, stop. Don't do this. Never start a experiment that will break your application. That's when you go back to the drawing board, improve your application to withstand this, because you only want to test things that you actually think your application should be able to withstand. So then we're going to execute our experiment. My idea is to start really small. Start with the least amount of users that you can impact. Start on staging environments if possible. Start with the least amount of impact for everyone. In such a game day, make sure that everyone is involved in fixing stuff that might go wrong. Make sure they're notified. And when your application withstands the first testing, you might increasingly increase the blast radius, right? So first we're just going to send 1% of the users there. We're going to send 5% of the users to the broken service and see what happens, right? So we always keep with our hypothesis. So only do stuff that you know or you think your application should withstand. And you could use a large number of open source tools that are currently out there. There's also some commercial tools. Well, the most famous tools are probably the Simian Army. They're created by Netflix. Well, one of the soldiers in the Simian Army is the Chaos Monkey, which is probably the most known tool for chaos engineering. But you have, over the years, multiple tools have come into play as well. The Chaos Toolkit is a nice toolkit as well, which is open source on GitHub and is getting more and more traction. And then you have Gremlin. Gremlin is a startup company that actually delivers a software as a service solution. It's a paid solution. They do have a initial free version where you can just do shutdown attacks and I think it was latency attacks. And those kinds of attacks you get for free, but they have a large category of like 12 different attacks that you could just execute on your servers or on your containers. They just have a Gremlin sidecar that you could add to all your containers, or they have a agent that you can install on all your servers. And from there you have one control plane, and you can really easily create these kinds of experiments, execute them, and also abort them. So yeah, Gremlin is a really nice way to start, especially with the free version now. And yeah, it's just tooling that makes these things possible for you without having really explicit knowledge about all these things, while the Chaos Toolkit and Simian Army have a far higher learning curve. So after we've executed our experiment, we're going to the learning phase, right? So, we survived our experiment. What should we learn from this experiment? how fast were we able to recover from a certain incident? When a database goes down, can we fail over to another database, or can we, how fast can we fix these problems? Uh, Even more important, how fast did we detect that we actually had a problem? This is one of the main problems when I try to do these things with our customers. Um, Being able to monitor these things, being able to observe these kinds of failures is something that most companies don't have in place yet. And a really important part here is, do not blame anyone that it's their fault that the application went down, right? It's not the developer's fault. It's not the operations fault. You together as a team who created the experiment, you were all on the same page that your application was going to withstand this experiment. So you're all responsible for this experiment. Well, so after we did the experiment, we go into fix, right? That's an obvious step. So we implement a fix that will actually, um, in the future, we could withstand this experiment, and then we just rerun the experiment again to see if our hypothesis is actually right this time. And after that, it's an important step as well is embed this into the culture of your application, of your team as well, right? So you can use these kinds of experiments to onboard new people. When you have new people who get pager duty, you can run these kinds of experiments where stuff goes wrong. You know your application in the end is able to cope with this, but you can simulate certain outages that people on call can train with. It's actually a nice way to do these things, right? We in buildings we do fire drills with people, so we train them on when stuff goes wrong. People actually know what to do. Well, when people go on pager duty, you just give them a handbook. When stuff goes wrong, please do this. But having actual experience with stuff going down is far more valuable. So doing these experiments in a controlled fashion actually is really valuable in training these people. And when you're really embedding this into your culture, you can add continuous chaos. Companies like Netflix do this all the time. They say when you create a new service, what they actually do is we will kill that service at certain amount of times. So make sure you're running at least 3 or 5 of them. So we will kill that server every couple of hours at least. Having that notion up front, you will build better architecture that will be able to cope with these kinds of things. This is something that's a next step when this is really something that you're doing in your company. But first, start doing these initial experiments. So having this into your culture, in the end, will make you build better architectures for your applications. So yeah, we've looked into doing these experiments, but well, of course, you also need to make a software architecture that's able to handle all these kind of outages, right? So there's a number of architecture patterns that you could use. We don't have time to go into all of them. But there are some things like, well, asynchronous communication really helps, right? If messages are just in a certain queue, you could just resend them, replay them, those kinds of things. Idempotent APIs. Well, if a message, if you're not sure if a message was received well, with idempotent IPAs, you could just resend the message without changing stuff in your application. Stuff like circuit breakers. When I do a certain call for amount of time, when things go wrong, we can flip the switch. We can stop pulling this database, and we might read stuff from another source. Since my time is almost up, I would like to wrap up with a few things. chaos engineering is not only a technical thing. It's really a big culture change for your company as well. Um, I think it's something that it's really nice to start experimenting with. Um, but yeah, it can be quite hard. So it's not just installing some technical tools and see what happens. It's really something that you have to change in the engineering culture of your company. Um, but what I really like is, in the end, you will have teams that are far more capable of taking resiliency into account when building your application. Um, and from there on, just start doing experiments. Um, observability here is really important, right? You can't do experiments when you don't have any vision of what's going on in your application. And especially distributed applications, having this observability is yeah, it's quite hard to set that up correctly. So start experimenting, but start experimenting really small, and just give these tools a go. There are several free options, several open source options. So, well, just give them a spin and see if they work within your company. So what I like to do is end with a quote by Nora Jones. She's one of the well, key people in the chaos engineering community, and her quote is like, "Chaos engineering doesn't cause problems; it only reveals them." Thank you very much.